Here we go. Let's dive into these problems. The impulse momentum problems are on the level 2 side. I didn't have any on the level 3 side, level 2. So it should be easy peasy lemon squeezy. Very good, Billy. Okay, so here we go. Number 2, Roger throws a tennis ball. This is the first one. Second problem on the set 2. Okay. First problem of the day. Roger throws a tennis ball at a wall. A tennis ball has a mass of 0.5 kilograms and a velocity of 30 meters per second. So here is wall. I'll make it a nice looking brick wall. And I've got ball. It's a tennis ball. And it's zipping along at 30 meters per second. Nice fast tennis ball. Only has a mass of 0.5 kilograms. Question 1, does it have momentum? Answer, of course it does. It's moving and it has mass. It's got momentum. Okay. Hits the wall in tennis ball, so it bounces off the wall. Boink. Comes back. Now, when it comes back, it's not moving as fast. It lost some energy to the wall, gave some of its energy to the wall. 20 meters per second. So it comes back 20 meters per second. All right, thinking. Okay, there's several questions here. Let's go through them. Now, second one, the ball's in contact with the wall with 0.2 seconds, so it's in contact with the wall for 0.2 seconds. A, what is the change in momentum of the ball when it strikes the wall? Okay, the momentum going to the right, 30 times 0.5, do the math, 30 times a half, 15. So going to the right, it has 15 kilogram meters per second of sweet momentum. Going to the left, you want to get the change. So to get the change, you got to know two different things. Coming in, coming out. 20, still the same tennis ball, so the mass is 0.5. 20 times 0.5 is 10. So going back to the left, notice that I'm going to draw this arrow longer than this arrow because momentum is a vector. It is a vector, yes, so it has an arrow distinguishing thing. So 10 kilogram meters per second. Okay, it wants to change. Simple enough. Piece of cake. Today the temperature is 55. Yesterday it was 63. What's the change in temperature? You know how to do that. Subtract 8 degrees. Piece of cake. Same thing here. Just subtract them. Right? You ready? So you're all saying 15 minus 10. The change in momentum is 5. Wrong. What? You said change is subtracting. It is. I did calculator. 15 minus 10. So right there. 5. Wrong. What? It is 15. You are subtracting. You are subtracting 10. However, you're not going to get 5. Pourquoi? These are vectors. That means to the right and to the left are different directions. By definition, unless otherwise stated, the convention is you go to the left with velocity, you're negative. Ooh, that's how we distinguish between the two directions mathematically, positive and negative. So you're going to get a negative. You're going to the left. So it says negative minus negative 10. Subtract a negative, add them. The change is 25 kilogram meters per second. Some of you might be not happy with that. Your brain's going scratchy because it was 15 and then 10. How can it be 25? Actually, scratchy this. Here's what's going. That's a huge change for this ball. Huge. You've got a ball coming in at over 60 miles an hour. Hits the wall. What's it have to do? It has to come in, stop. Then it's got to turn around, go back the other direction, and go from 0 to over 40 miles an hour in the opposite direction. That is a massive change. A change from 60 to 0, turn around, go back the other direction from 0 to 40. Big change. That is a massive change. Yeah, that's called impulse, people. When something bounces off of something, that is a huge change. A typical physics problem or this little thought problem. Usually you'll be given something like this, like a multiple choice question. They'll say, there's a door, and yeah, here's a door. Doorknob. And the door can open and close. You know, it's not shut all the way, so you can open and close it. You take three things, like some clay, a 1 kilogram mound of clay, throw it at the door. You hit the door, door moves, right? Take a 1 kilogram rock, okay, 1 kilogram rock. Now the clay, we're assuming I use clay because the clay is going to stick to the door. The clay will go in and hit the door, stick to it, and move the door. The brick's not going to stick, or I use a brick, use stone, brick, whatever. So the 1 kilogram stone or brick is going to hit but not stick. So hit and go, kind of just fall to the ground right there. What if I used a 1 kilogram bouncy super rubber ball thing? Hit that, bounces off, comes back. Which one of the three will make the door open more? Or maybe you'll say they're all going to make the door open the same amount. If they're all moving the same velocity, they all have the same mass, shouldn't they all do the same job on the door? So they move the door maybe a little bit. Answer, no. If it's clay, clay comes in, hits that door, sticks to the door. That door, let's say this was a ball of clay, not a tennis ball. So a ball of clay, 1 kilogram, the amount it hits. The change in momentum is going to hit and strike is from 30 to 0, and that's it. You're a ball of clay, so you're stuck. So the change in momentum is going to be 30 times 15, or 0.5 is 15. That would be your change in momentum of the ball. Now here's something we have to know. It's called the conservation of momentum. Important law in physics. Momentum before something happens, usually a collision, but not always. It can be something like a bullet coming out of a gun or a rocket ship firing its engines and going forward. That's all momentum stuff, and we'll get to that. But it comes down to conservation of momentum. So if there's a certain amount of momentum before, there's going to be a certain amount of momentum after. Before collision, after collision, momentum must be the same. Conservation of momentum. If you're a ball of clay and you strike that door and you stick, your momentum's gone. You're not moving anymore. Where did it all go? To the door. So the door is going to move some. All right? Now, if we hit the door with a brick and the door goes, and the brick falls, doesn't stick to it, but doesn't bounce backwards either, we're going to get just approximately the same result. The brick comes in, falls down, momentum over for the brick, transferred its momentum to the door, door moves a little bit. But what if you have a super bouncy rubber ball, and it comes in and it hits and it bounces off? Hey, that's just what we did in the last problem. Tennis ball is a bouncy ball. So in that case, the change in momentum is much greater. It's a much greater change in momentum. So the momentum change is going to cause a larger change in the momentum of the door. So door's going to move more. All right, see? Physics. Makes you el cinco grande. Okay, that's the first problem there. And I did some blabbering about other things, but that's a nice little problem to have in our hip pocket. Put it in there for our El Testo. All right, we're going to keep this video a little bit shorter, under 9 minutes, just faster for me to load the video, and I will go to the next problems next.